I would like to welcome you guys on our discussion on INOFEST 2021. The topic is AI and possible opportunities, and I would like to introduce our three speakers. First is Jasmina Popovska. She's a senior business creation manager in EIT Manufacturing. Second one is Michal Gregor. He is a researcher in the field of artificial intelligence and machine learning at the University of Žilina. Welcome. And the last one is Imrich Berta. He graduated in applied mathematics at University of Cambridge, where he was developing the new machine learning models for disease prediction, and he works in data scientists in the healthcare industry. So welcome, guys. I would like to maybe give you easy question at the beginning. So can you maybe describe yourself, where you are currently working and on what topics you are currently working?
I can start, of course. Jozef, thank you very much for the invitation, and thank you very much for this opportunity to share our standings on a very important topic, at least from manufacturing point of view. I'm based in our Vienna office in the Technology Centrum in Zielstadt in EIT Manufacturing. We have a co-location center that is covering the Central Eastern European countries. But of course, our headquarters is in Paris, and we have our colleagues based in the other countries covering all over Europe. So EIT Manufacturing in general is supported and financed by the European Institute for Innovation and Technology, that is a public body of EU. And my job within EIT Manufacturing is mainly to support startups, scale-ups, and small and medium enterprises in their expansion in international markets and of course in their growth when it comes to investments.
Thank you. Michal?
Yeah, thank you. So I'm currently at the University of Žilina. I've been doing AI and machine learning related research for some time now, and I'm mostly focusing right now on deep reinforcement learning, which has a lot of applications across robotics, recommendation systems. And right now, what we're looking into are applications in traffic control. So that's kind of what we're mostly interested in now. And yeah, so I don't know what else. Probably that's sufficient.
Okay, Imrich.
Yeah, thank you, Jozef, for having me here. I'm working as more on a data science branch in a healthcare insurance fund in Slovakia, and we are just trying to use all the data possible to predict diseases, to predict fraud in a healthcare sector. I previously worked solely on frauds in Slovakian healthcare payments. There is an estimate that 5 to 15% of healthcare payments are fictional or upcoded for something that didn't happen. So obviously there is a massive need to cut it down.
Okay, thanks for your introductions. I would like to start with a definition, and then I would like to move to the business in the following question. So first of all, for me as a business person, I firstly realized that there is something like AI, but not necessarily, I'm not sure if it's AI, when the computer won in a chess, again, the best chess champion. So, but from what I understand, the machine or computer was purely reactive. Then when I'm looking at what's happening in public discussion is there are going to be robots which are going to be self-reflective and self-aware. And this is something what may even possibly cause us problems. I don't want to go too much in a topic of ethics here, but I would like to ask Michal and Imrich, what do you think, or what's the definition? What is AI and what is not AI, and what AI can do and what AI cannot and will never do? So what would be your explanation and maybe understanding of this?
I can start by a simple definition. It was provided by late MIT professor Marvin Minsky, who is also called father of artificial intelligence. And he said that artificial intelligence is science of making machines do things that would be considered intelligent if they were done by people. So you mentioned the chess example. That could be, if you are only looking on a narrow game, that one game of chess, the AI would be considered intelligent because the AI beaten the human player. What we don't have is something called general artificial intelligence. We are probably far away from a AI system that could totally mimic the human intelligence. So right now we are good at something called narrow AI, which are like simple tasks like diagnosing a cancer, playing Dota, playing chess, recommending which thing you want to buy from Amazon.
Okay, and like when we are looking at this, but like as a definition, what AI can do and what AI can not do, like, so where is the limit in the science, I would say?
Go on, Michael.
Yeah, I would maybe just like to add to the definition, because it sounds like a very simple thing to define like the basic terms of the area, but actually this is something there's been a lot of controversy about, and so essentially the community has been arguing about the definition for about 50 years now. So it's actually not that easy, and there have been many approaches, and one of them, you probably know, the Turing test, right? So you sit a person at a computer, they're chatting to an entity, and they're supposed to well, essentially tell whether they're chatting to a human or to some kind of artificial intelligence, right? And if they're not able to tell the two apart, then you have a system that's artificially intelligent. However, there are problems with that definition, which are perhaps even philosophical, because if you are that artificial intelligence, then you'd better not answer correctly when they ask you what the square root of 2 is, for example, right? Because a human doesn't know that. And it's not really apparent why artificial intelligence shouldn't know that, but under the definition it shouldn't, right? So that's not very good. And what we are working with now mostly in terms of definitions is that the system should be able to act rationally. And by rationally, we mean roughly optimally with respect to some criterion. So that's really where this machine learning happens nowadays. You have some kind of criterion that you're optimizing for. You want the system to be able to perform classification, or I don't know, some kind of decision making according to some criterion. So that's really also maybe partially the reason why we're focusing now on the kind of narrow AI, because this criterion kind of invites that kind of approach, because you always have a criterion that's specific with respect to some particular task. Well, one thing that I would also like to add, we often tend to, I mean, mostly the public often tends to think about AI in terms of what we really can't do yet, like maybe these cars, these autonomous cars and stuff. And we can't really do that very well yet, definitely not with very good safety guarantees. But there is a lot of stuff that we can do already, like we are essentially using AI, well, not in the strong sense, but in the narrow sense. We're using AI every day, right? You have smart keyboards in your phones, you have maybe speech recognition, you have text-to-speech. I'm using that every day. Then you have maybe face clustering in Google Photos. You have now YouTube and Facebook are using actually deep reinforcement learning to recommend stuff to you, which has its risks as well. We might get back to that later, but there is a lot of stuff that we already have that we are using daily. So.
Yeah. Okay. I would like to jump to the topic of practical uses, so we can actually maybe get closer to our audience. So maybe if all of you can maybe say what you are currently working on, so we can see what's possible in our projects currently, and then like as a second question, like in another round, I would ask like regarding like some of the marketing materials, so if we should be afraid or not. So maybe I would ask Jasmina if you can maybe present some of your like practical uses or projects you and EIT Manufacturing are working on.
So when it comes to the manufacturing sector, we believe that it's one of the leaders in application of AI technologies. And the benefits can be multifold, like from significant cuts in unplanned downtime to better designed products. So, however, mainly AI currently is used in the predictive maintenance for the machines in the industry. So I have one presentation that I would like to share with you. Maybe it's easier to structure a bit what we do and provide some examples on projects that we have run in the past related to AI. So in general, we try to link the role of AI with the digitalization, because the digital transformation is also fueled by data, and the data that is created through the collection from the machines and collected, and it can be a useful source for the artificial intelligence application. So somehow we try to think when we talk about AI in the manufacturing sector from this perspective. So, for example, data can be coming from different, let's say, aspects. So it can be related to the movement, acceleration, vibration of mechanical parts. It can be related to collecting information about the temperature and heat transfer of different kind of materials, noise and sound, and etc. So it can be, let's say, AI can be a critical enabling technology for digitalization and integrating processes vertically across the entire organization, from product development and purchasing through manufacturing and logistics. We see that when we talk about AI in manufacturing, we always, let's say, rely on the role of data that is collected from the industrial environment. And when we deal with the data, the data collection, we also deal with different kind of sensors to capture those data. So sensor technology is quite important in this aspect in order to enable at the end to have AI applications. So we also talk here about mathematics and mathematical algorithms and models that calculate the behavior of the physical objects. So when we see on this slide, we can talk about the blueprint for system design in the digital age. And we believe that it's not just about artificial intelligence, but let's say it's also on the high level of software design. It's also important to talk about deployment and exploitation of AI hand in hand with this mathematical modeling and simulation. So on the upper side of this slide, we can see the smart products. Every equipment can be enriched with these digital functionalities. Every manufacturing company should ask the question, what does it mean for their products and for their services when it comes to smart factory and smart products and smart services. So this is, let's say, the connected with how we can exploit all the data that we collect from design, testing stages to the end user in the manufacturing sector, and how to develop new businesses and services from this data. So, of course, here also comes the questions about cybersecurity, a topic that is very important for the management of manufacturing companies. So, data sharing is another topic where every participant in the platforms can have a fair share in the value of the data. So when it comes to smart factories and smart products, we are also in the digitalization of the traditional industry and smart services in the digital economy. So we have few projects in manufacturing. One of those is a manufacturing data space that let's say started last year. And some of our industrial partners are jointly creating sandbox data space where they collect and share data. And also a demo app of decarbonization in the industry was developed based on this. So this project is actually a way how we can also cooperate and create an ecosystem in the industry around collecting and sharing data and contribute towards decarbonization of the industry. But also here we have started certain activities connected to Gaia-X, European Initiative for Data Spaces. So another cross-kick activity that is done together with EIT Digital is and also EIT Health is the production of a joint report on AI, where here we try to target, to address the challenges that are currently with the EU legislation regulation that is relevant for the topic. We have here in this quite interesting report that we also advise that it's read, we tackle the problem of GDPR that regulates the privacy of data, and that our standing is that there should be a specific legislation when it comes to data gathered from machines, because these are not data that are, let's say, same as the private data. So there is quite a distinction here. Also, when we talk about AI and the impact on the manufacturing sector, here we can talk about how it changes the working environments in the manufacturing sector. So people in the factories, not just the blue-collar employees, but everybody will be influenced by the AI. So there is a research from the World Economic Forum that foresees that with application of AI, there is expected still a growth in job, so not a decrease, and with the digitalization, but the main change will happen in the need of skills and the need for upskilling and reskilling of the workers on the factory floor. And there is already a gap between the openings and the hires in the manufacturing sector. And on the last slide, we have here some, let's say, inputs from what type of, let's say, tasks and roles the people, the workforce, will focus on in the future. And the prediction is that there will be a greater demand for high educated people, for, let's say, the automated, manual and repetitive tasks will be done by machines, and soft skills like teamwork and networking will be more and more needed. So we as EIT Manufacturing, it is a knowledge and innovation community. Part of our activities are quite focused on education and upskilling and reskilling workforce in the manufacturing sector in order to provide the skills needed for the future of the manufacturing sector. So let's say that we are quite optimistic on the changes that there will happen due to digitalization and of course AI in future in this regard, and that, let's say, people will be more engaged in monitoring and doing more complex works, while as the supervisors, while the repetitive tasks will be, let's say, replaced by machines and by AI. So I will stop here with my presentation.
Yeah, thanks, Jasmina. Like, when I was listening your presentation, I was thinking that, like, firstly I had a question like, will robots and AI systems replace us? And then when I was looking at, like, when we care, well, the human, they don't have a capacity of the robots and computers. They don't have a sensitivity of the sensors. They cannot, like, we cannot feel the sensor, like the moisture, the noise, and so many details. So I was thinking, like, we had in INOFEST, we had futurist Gerd Leonard, and he was talking about the topic that everything what can be digitalized will be digitalized, and everything what can be automatized will be automatized. And based on this, I see that well, for safety and automatization and even like effectiveness, of course, everything like from AI perspective and machine learning, which will be helping us to, you know, keep the production and manufacturing better, it will be applied. I would ask Michal, like regarding the Slovakia. The Slovakia is actually coming from historically from mechanical engineering, and when we are looking at like the presentation of Jasmina and also like your experience, what do you think, how far we are in Slovakia with applying AI solutions in our manufacturing and mechanical engineering industry? What do you think? Like, are we too far behind some countries, or we are doing okay and we already are applying quite a lot of solutions?
Well, it's difficult to say because I'm not that like conversant with what they're doing in the individual factories, but there are certainly several groups. There is a robotics group in Bratislava, which Professor Duchoň leads, and they're doing a lot of good stuff. I'm not sure I would call it artificial intelligence, really. They're doing advanced robotics. That's definitely true. They are even doing some machine learning and stuff like that. I'm just not sure I would you know, call it artificial intelligence per se, but they're doing good work. And we also have groups in Žilina, and there are even these spin-offs, and they've been doing internal logistics, for example, using these autonomous guided vehicles. So I think we do have some applications, certainly, even from the universities, you know, in these companies in Slovakia. So I think we're definitely doing something. I'm not sure I can really compare us with what they're doing elsewhere, you know.
Yeah, and also Michael, so can you describe some of the projects you are involved in, which are currently in Slovakia and they are AI focused?
Well, let me think. So we have several groups at the university now. One of them, they're doing a lot of this visual stuff using deep learning, and they're targeting several things. So there are like traffic-related applications where they're, for example, doing tracing of vehicles. They're also doing, and we have several groups, in fact, which are doing healthcare applications, which is also very interesting. And it's kind of challenging as well, because when you really think about this stuff, what we're doing with deep learning, visual kind of computer vision tasks, usually you pre-train on large data sets. Like there is this ImageNet data set which has millions of these like real world pictures, and you pre-train on that, and then you just transfer to your own task. And that's kind of easy to do with most computer vision problems. It's less easy to do with healthcare related problems because the data is very specific. And it's not, you know, if you're tracing blood cells, for example, it looks very different from natural images. So that's kind of, and you usually don't have that much data either. So it takes some very clever engineering to work around that. So there are definitely applications like that. Well, also, like I said, we are now looking into these traffic control kinds of applications, which I think is also going to be very interesting. You know, the traffic volumes are increasing. We are starting to experience the problems they have in the big cities now, even here in Slovakia. Definitely, we feel it in Žilina, where, of course, we need to improve the infrastructure as well. But the control part, I think, is also lagging behind. And there is a lot of interesting issues in this sector. For example, I don't know whether you've heard about that, but well, obviously one would think that with all these like navigation softwares, like you have Google Maps, Waze, and they have dynamic kind of information about what's happening in the city. So they keep you know, telling you how to reroute in order to avoid congestions, for example. But I don't know whether you knew this, but actually they're making things worse. Because the way they're redirecting traffic, they're not really taking into account what's going to happen when they reroute all vehicles onto these like minor roads with which are very narrow and can't take the amount of cars they're sending their way. So they actually are experiencing this problem and have been for several years in large cities in other countries, and now these applications are on the rise here as well. So, you know, this kind of artificial intelligence-based analytics application can have downsides when you don't really think about what you want to achieve in the long run. But yes, definitely. So there are these applications. I don't know what else. Obviously, there is robotics. We've mentioned that. Yeah, maybe let's move on.
Yeah, I mean, we will connect with Imrich, like, because you mentioned that the healthcare is and medicine is potentially, I mean, like, huge opportunity, like especially like for saving lives and like prediction and life disease. Imrich, maybe you can describe. You've been studying abroad, like you were in Cambridge, and you spent some time in Zurich. Currently, you are working in Slovakia, and like we had multiple discussions about healthcare in Slovakia and how we can predict the things. So what's your view, and what's your projects you are currently working on?
I would say in Slovakia in general, we are on like level 0 or level 0.5, but this is the level that has to be done properly. We want to gather data in a structured and clean way. And that's the thing that is still not sorted in Slovakia. There are some entities doing research, very often research on foreign data, on some database that's publicly available. But what we are really working on now in the National Center of Healthcare Information is mainly working on is creating a database of data that we will later be able to use for research. There is still not yet a single entity that can provide the data for academia, and that's why I'm saying that we are not on level 1 yet, like applying AI in every subfield of medicine and public healthcare. Like there is this narrow application I mentioned, which is fraud detection, and this is cool because my major motivation for me to work on that is to have a clean data in the future. So because there is a medical fraud, that there is some of the data didn't biologically happen, we have dirty data. But if we prevent it by algorithms, and we will improve the culture in healthcare to not claim stuff that didn't really happen, we will have much better and cleaner data in the future. So because in machine learning, there is this saying, garbage in, garbage out. So if we're gonna have a dirty data with the stuff that's not real, and we're gonna pour that dirty data to algorithms and even the best deep learning neural networks, we will not have a good outcome in the future. So at the first place, we have to make a database that the academia will be able to use in the future. And one important step in the process is making sure that the data are clean, and they stand for what really happened in the ambulance or in the hospital. When I am saying fraud detection, we also don't have like a perfect database of past frauds, saying this was fraud and this was not. So we very often work in an unsupervised setting. That's a type of machine learning where you don't have a specific label, you don't know what you are looking for, but in a fraud detection field, we are looking for some outliers, some doctors or ambulances who are treating patients in very weird way, very often very expensive way.
Also, like Imrich, when we talked like some time ago, like you actually showed me how you can actually help to predict that some disease will affect like the people based on the historical data and results. Maybe can you describe some of those, like what you already find? Because you mentioned also previously that you were working with the health insurance companies.
Yes.
And yeah.
So that is a subfield of machine learning in biotech called personalized risk score. So we are using all the data we have available, and we are predicting, for example, if the patient is getting certain disease in 5 years or in 2 years, or and then that's still in very developing phase, and we are still learning how to make sense of the data, and we are very aware that there is some dirt in the data that we don't want to use. Yeah, so the prediction can be made on a sociodemographic history of patients or injuries, and also the past diagnosis and drugs given to a patient. There is a lot of stuff that we can do in the future. We can do something like targeted screening. So we can pick up 100,000 people most likely with the highest risk for some disease, and distribute a screening test to them. We can also work with general practitioner ambulances and help them with diagnosis or navigate them to take a look on this additional factor or do these additional blood tests to confirm the right diagnosis.
Okay, so but anyway, like when you are describing like because we have a discussion about the AI, but like I'm trying to understand, like one thing is to collect data, second thing is to understand data, then to third step I would say is like decision, and then is acting. And in some way I'm looking at like in some way we still don't have like sorted data in some way, and we are only trying to do the data analysis to help to make decisions, but like we still, I feel, but I'm not saying, but I just feel based on the discussion that we are still far from having machines which we can actually like have enough data to act real time really fast. But yeah, I will ask later in another round. Jasmina, maybe if you can describe, like, because you said that you are working also like with bigger projects, but also with the startups. Can you maybe describe, or maybe well, say something about like where is the potential for startups when you are looking at well in Europe potential? That's one thing. And second thing, where you struggle in a AI topic of manufacturing. So basically, is it like going very well, or what is like the maybe typical problem with the manufacturing companies? I would say applying AI solutions. So two topics, and those can be skeptical, but also like I would like to see in the second round the positive outlook of direction. Yeah.
Thank you very much, Jozef, for the question. So we work daily with a lot of startups having certain AI solutions. Sometimes they are only software solutions, but very often these are hardware and software solutions combined. However, the use cases are very specific, and most of the startups we are working are trying to improve the performance of robots and cobots and how they perform different tasks, let's say, and working with different materials, because they try to make them smarter, even smarter than what they are at the moment. Some other, let's say, focus on improving the quality control in certain industries and helping factories to, let's say, reduce errors, reduce the, let's say, return products from their customers or unsatisfied customers, or let's say try to reduce scrap. So this is a kind of a also green impact that sometimes AI solutions can have in the industries. Sometimes it's when it comes to the robots, also about the safety of the employees working with the robots and improving this area, so solutions that work in this domain. But in general, these are, let's say, more focus solutions, specific solutions. They're not applicable to all sectors because they're quite niche, maybe focused on niche markets and on certain use cases. So the scalability, and here it's under question, and how easy these kind of solutions can be replicated in other environment, in other factor. Probably the best way would be when there will be a more radical transformation of the manufacturing sector, when the manufacturers will move towards service-based managing of the full life cycle, from the planning the consumer preferences to the delivery, through the production to the delivery, and having the full industry 4.0 vision actually achieved by as much as possible automation of the processes and let's say prediction, and making sure that the final outcomes can be controlled and predicted, and this is quite precise. So in general, we are far from that because of the limited maybe application cases, but there is, let's say, startups that work with predictive maintenance that are somehow the market here becomes a bit crowded with so many startups providing solutions for the predictive maintenance. The good thing is that they are somehow solving issues of different sectors and different type of factories. Another thing is the SMEs and how much SMEs can use this kind of technology. And there are certain maybe limitations and gaps between countries Europe-wide, how much it's developed, let's say, certain research on the topic of AI applications in industry, how much data is gathered on a national level, etc., and available, of course, and how much SMEs have access to this kind of technology. So we also here see certain, let's say, challenges to work on in future.
Okay, I would like to ask Michal, because like Jasmina just told, like from what I understood, that we are actually not that far, but like there are already so many projects going on, and like the market is starting to be somehow crowded. Michal, what do you think from science perspective? How far is the science with AI in the means of what is already used in a practical world and what may be used? And probably it's very hard to describe, but I just would like to know, because I would maybe share the story, and like we are always, from marketing point of view, we are listening that very soon everyone is going to have electric cars, and we will not drive them because they're going to be, you know, driving like automatically based on AI. And this is one thing. Second thing is like we are always listening about self-aware robots, and they may endanger us in some way. So, and I just would like to know how far we are from this. Like, is it something like only telling us that this is the future of AI? Because I would like to understand how far we are. And like another question I will ask in another round is that where we should invest our focus in following year 2 or 3. So how far we are with science?
Well, what I think is that actually we're not that far, but nobody knows. You know, we can't really predict what is going to happen. But like based on what we have right now, we're definitely not as far as many people seem to think, because we do have some. I don't know if we can even call them autonomous cars. But okay, so let's say we have some autonomous cars now. They are definitely testing them in some countries, but what we can't really provide are any safety guarantees on how they are actually going to work. In fact, I don't think we even know what we want the safety guarantees to look like. I don't know that we are especially sure about that. And so what can happen, and this is a huge, I think, a huge risk. These systems are quite good, in fact, very good, sometimes better than humans at doing computer vision, for example, and you definitely need that in the autonomous cars and all these applications in healthcare and stuff. But what you can do, you can actually generate these adversarial examples where you as a human wouldn't be able to even tell the difference between a regular image and the adversarial example. And the neural network gives completely ridiculous predictions. Like you have the image of a lion, for example, you make subtle changes to it, and then the neural network predicts that it's, for example, a tank or something ludicrous, you know. So, and we thought this is very unlikely to happen in practice, but actually it has now been shown that there are natural images where this sort of thing happens. And this is actually scary, right? Because you're driving maybe, or not driving, right? Your Tesla is driving you to work, for example, and suddenly it's, you know, it observes some kind of visual input where it's going to affect it adversarially, and it's going to do something crazy, and you can't really rule it out. So you know, this is kind of the main issue right now. It's not even that you can't train systems that perform reasonably well. It's just that you can't be sure they're not going to fail miserably in some scenarios. You just can't provide the guarantees. So definitely in safety critical applications, this is a problem. Although it's not always a problem, right? Because sometimes you have applications where you can provide basic safety guarantees. For example, you're controlling maybe traffic signals on an intersection, right? So what you can do there, you can always make sure that the light phases don't conflict, right? So you can make sure that there are no, for example, car crashes. That's relatively easy to do. What you can't do is make sure that your AI-based controller will actually be spectacularly bad in some situations, and it will slow the traffic down. You can't really make guarantees about that, but at least you can put guarantees on the actual safety of the intersection. So that at least gets you a certain distance, right?
Yeah, thank you for your explanation. And maybe Imrich, what you would say from your perspective, because you said that we are at point 0 or maybe 0.5. This is in Slovakia in the data gathering and collecting and sorting. But when you are looking at science from world perspective, how far we are, and like, is it going like fast, or it's going to take as long that maybe we may even not see the results in some way?
Mathematically speaking, what we call AI today is just carefully tuned mathematical operations and differential equations. So some people think that the next discovery in AI will be so big that everything we call deep learning and machine learning will be just some sort of optimization. They will be considered as optimization algorithms as we know them from different fields from 50 years ago. So, and those deep learning systems, they are really large. They have a lot of parameters, and we don't understand them completely. As Michal said, there is this uncertainty that we cannot guarantee what they will do with some random combinations of pixels they will see. But exactly, like, there is always engineering that we can always make sure that there is some hard-coded rule in a hierarchy above the deep learning, which we cannot completely guarantee the decision. But yeah, mathematically, I consider them as just a big bunch of mathematical operators, and but carefully tuned to be good as a specific task.
Okay, so for me as a listener, you know, like, it's hard to say even like what is AI, what is not, but it's probably even like very hard to decide, explain it. But okay, so we have data, and like I need to, well, because my understanding is like when I have some kind of machine which is based on some kind of data doing the responsible decision and reacting. Okay, but let's have a last round of the questions. I would like to ask, like, because like, of course, we are not going to, like, for example, in Slovakia, we're not going to invest to autonomous cars, or we are not going to probably invest too much in robots. Maybe yes, but the thing is, where do you see the most business potential, where we should have a focus and even like invest time and money in following, let's say, 2, 3, 4, even 5 years, where we should focus, what can be improved and reachable, what is reachable in such time?
There is one interesting field, which is programming itself. So there is this estimate that the global cost of debugging, which is basically programmers staring at the screen trying to figure out the problem why the code is not working, the global cost of that is $320 billion. So any AI system that can help with that will have a great potential. And there is also translation between programming languages. At some point, one Australian bank spent $750 million for translation from some old language to Java. And those things, we spend resources as a society on those things on a daily basis. So there is actually in programming itself, there is a massive market to help to make coding and programming efficient.
Jasmina, maybe I would like to ask you, because you are also like the coach and mentor with the startups. So you made the decision to maybe like even like invest and coach startups. In what startups in topic of AI and manufacturing you see the most potential in the following years?
So it can be many application cases, as we discussed so far in the manufacturing sector, as we mentioned, from planning, from working with the customers and planning their products to the delivery at the end. So it's the full process. There are many opportunities to improve it and to make it more autonomous and to replace repetitive tasks. Again, when it comes to, let's say, AI solutions, we are considering AI solutions that can be easily scaled and that do not need a lot of investments for every project when they have a new client to be onboarded. So investment-wise, this is one of the aspects that it's very important, whatever use case it is. Another topic that we discussed, it was with the robots and making sure that employees are safe and making sure that robots are becoming more and more performing better and smarter. So I would say that this is something that we are looking into. Of course, predictive maintenance is still interesting, but it really depends in which sectors and where there is not that much, let's say, not many solutions are already present and solving this problem. So I don't think that it's, let's say, the future where it will be. It can be anywhere in the manufacturing, but it is more related from investment perspective, how scalable this is and how big the market is, and other, let's say, questions related to the business side of the startups, not so much on the technical side.
Okay, and I will ask another question. For me, from business perspective, I'm just trying to understand where the AI startups in manufacturing, but not only, are from your perspective. Is it like I'm always calling it a first step. First, I just want to save money. Then I want to, well, I would say, speed up the production. And like another level for me is the, I would say even like the higher in the quality. So where are the projects and applications currently? They are at the beginning like trying to make less faults and replace people and save, or they are even like those that we want to have a machine which is going to do such things that we, like it's going to speed up the process of development of products and everything.
Definitely, that's why I believe that it's at the moment the most crowded market in the predictive maintenance, because some machines are very expensive, and the production also, when it's stopped, it's very costly for the manufacturers. So it's a huge potential in this regard to solve this problem of unplanned, let's say, downtime of machines and stopping the whole production line because the machine had a, let's say, broke down. Or on the other side, having an expensive machine to be, let's say, or equipment to be in out of order, or cannot be even replaced. Has to be replaced because the maintenance was done not when needed, but quite late. So I would say this is one of the very interesting application cases still. Another one is, of course, with energy efficiency and the green impact and making the manufacturing more greener, saving waste, let's say reducing waste, saving resources. So there are many cases also on this side, because let's say this is the mission, especially in Europe, to have a more green industry.
Okay, so for me it's like prediction, safety, and saving, like mostly, but of course, like there are the projects which are like more in the development. Okay, Michael, from your perspective, where we should invest our money and focus, but at the end of the day, we would like to have practical applications within, let's say, 5 years.
Mm-hmm. Yes, I think what we mostly, well, the current state of the art, what it allows us to do is, I mean, there is a lot of stuff, obviously, like anything that's, for example, computer vision related to deep learning is pretty good at that. But what you need to ensure in order to have a practical application, and I think we've partially commented on it already, is safety, right? So wherever you have like a safety critical application, you probably can't really use these kinds of machine learning because you don't have guarantees. But sometimes you can work around that, right? As we mentioned, you can have the safety at another level. And this is even true, for example, in healthcare applications, right? So you might have a deep learning system that, for example, analyzes X-rays. And as long as you provide it to the doctor as a support tool, it's okay. If you wanted to make the decisions autonomously without the doctor, that might be a problem, because then there is nobody to check the result. And I actually have a story on that, and I think that that's going to also tie in very well with what we said about the quality of data, right? So this happened to a researcher at Berkeley. He's a very well-known professor in the field, Michael Jordan, right? Not the what was it, basketball player, different guy, right? So what he did, he went with his wife to see a doctor. Well, she was going to give birth in a few months, and so they did some, I think, ultrasound tests, and what they found was that the ultrasound had these little white kind of dots, and so they told them these are markers of the Down syndrome, and so she should go for further diagnostics, which are quite risky. But well, anyway, so they recommended doing that, and so what he said, so he looked at the images and he said, okay, but to me, I'm not a doctor, I'm a computer scientist, right? But these white dots, they don't really seem like markers, they seem like white noise on the image, right? So are you sure these are actual markers? And as it turned out, they weren't. They actually really were white noise. And this started to happen to the doctors after they replaced their original machine with a newer one, which was a higher resolution one. They they essentially weren't able to tell the difference, right? So these new white dots were not actually markers; they were noise, and these were humans, right? So what happens when you do that to a machine learning system? When you change the type of the data, when you change the quality of the data, this is something we need to think about. You know, especially in these healthcare applications, you might have, for example, data from abroad, like we mentioned, but really what you care about is data from the kind of machine you are using in your hospital. Otherwise, the system might not work correctly. So I think that this is something to also think about. But I think there is a lot of actually applications which are not safety critical. For example, you have a lot of applications nowadays in entertainment industry, right? So you might want to use your deep learning for, I don't know, manipulating images, for doing things in video like deepfakes, for example. So Disney, I don't know whether you knew this, but Disney is now doing research in deep learning because they've been using a lot of CGI in their movies, and it's quite expensive, and it's not really easy to do well. And actually, these deep learning systems are able to do a much better job, but they're not able to scale them up to 4K yet. So that's what they're doing research on now. And this is actually fine, right? Because if it doesn't work, you can always fix it. You can tinker with it. It's not that it's going to cause harm to anybody, right? So in this kind of application, I think we're perfectly safe. So that's really where I think, you know, these kinds of applications where you don't have the safety-related context, or you can kind of work around it. So that's really where these applications are going to shine.
Okay, so for me, from my understanding, is like when we are looking at the business, like business decisions, I'm always looking, it is a must or nice to have. And this is like when we are in the topic of healthcare and medicine, and we see like the 7 lives, well, it's a huge thing compared to like any other any business, I would say. So there is a huge potential. This would be my understanding. Yeah. Okay, Imrich, what you would say where we see the huge potential in following 5 years, where we should invest money and focus?
I will just mention one similar story from the healthcare. So at some point, working for Ministry of Health, I interviewed a Slovakian doctor using AI-based recommender system for some drug treatment. And for one specific patient, 2 doctors claimed that the AI system recommended too heavy dose of I think it was a chemotherapy. And there is one problem with machine learning: it cannot extrapolate beyond training space. And there is the situation was that the patient was too thin. I think around 45 kilos, and the whole system was trained on American data. So we just guessed that there was no such a sample in the American data sets, and the AI system couldn't recommend the right amount because never seen such a sample. It's obviously half joke, half real feedback from the doctors that they had to stop. Kind of the recommendation and make their mind according to their knowledge and intuition.
Okay, guys, thanks for your contributions and thanks for the discussion. Like we already have like 40-45 minutes behind us. I'm very glad that you joined the discussions, and I would like to probably maybe like invite you for future discussions and maybe go even deeper with the specific topics, even like this separate panels and even like personal meetings and even the projects and startups in the topic. It seems that the AI is going to be future. It seems that we are not as far as the marketing, world marketing is telling us. But for me as a business person, it says that there is a huge potential to invest, and like from many perspective, we had a discussion also like previously that Slovakia is coming from manufacturing and mechanical engineering, so there's a huge potential here to apply those use cases, and also like as Michal and Imrich was saying, like the medicine is something what is, I would say, like chaos, not only here but probably worldwide, and there is a huge potential to apply that to even like save lives, making predictions in all kinds of directions. So thanks for the discussion, and hopefully see you soon in the discussions in the future. Thank you very much.
Thank you very much.
Thank you.
Jozef.